Here we are going to do divisibility tests for 7. Though we are not casting out values like we did in the other examples, we can still call the process casting out 7s, but it works a little differently than the others. Each position of a digit of a number can be expressed as a multiple of 10. So for example, if I had something like 252,379, this position right here, the 9, this is known as the ones position. That's 10 to the 0 power. That's equal to 1. The next number over this 7 here, this is known as the tens position. That's 10 to the first power. Of course, that's 10. The next number over, this is known as the hundreds position. That's 10 squared. That's equal to 100. This position here, this is known as the thousands position. That's 10 to the third power, that's 1,000. This position here, the next one over, this is the 10,000s position. That's 10 to the fourth power. In this position here, this is known as the 100,000s position. That's 10 to the fifth power. Now, if I was to divide 7 into each one of these positions, 7 goes into the first position here, the ones position, it'll give me a remainder of 1. If I divide 7 into the tens position, it'll give me a remainder of 3. 7 goes into 10 with 3 left over. If I was to divide 7 into this position here, they'll give me a remainder of 2. 7 goes into 114 times with 2 left over. If I was to divide 7 into the thousands position here, that'll give me a remainder of 6. If I was to divide it into here, this will give me a remainder of 4. And if I was to divide it into the 100,000s position, it'll give me a remainder of 5. And this pattern with these remainders repeats. This 1, 3, 2, 6, 4, 5, 10 to the 6th power, that's the millionth position, 1 remainder. To the 10 million power, 3 remainder. It repeats. So we have these remainders here, 1, 3, 2, 6, 4, and 5, each one representing a position, a tens position of a digit in a number, and we're going to use those to help us with our divisibility by 7, and I'll show you how to do that. So for letter A here, I'm going to write out 4, 4, 3, 2, 7, 5, and 7. I'm just writing out the digits to the number here. Then since this represents the ones position, I'm going to bring down the remainder for a ones position. That's going to be 1. Here's the tens position. This is the remainder for the tens. This is a 3. Here's the hundredths position. That's 2. Thousandths. Here's the 10,000ths. Here's the 100,000ths. And it repeats. So I start back at 1. Here's the millionths. Now that I have that, we simply multiply. 4 times 1, that's 4. 4 times 5, that's 20. 3 times 4, that's 12. 2 times 6, that's 12. 7 times 2, 14. 5 times 3, 15. And 7 times 1 is 7. We then go ahead and add all these up. And if the sum of these digits is divisible by 7, then the whole number here is also divisible by 7. So if we add all these up, these come out to be 84. And 84 is divisible by 7. 7 times 12 is 84. So therefore, 4,432,757 is divisible by 7. And we'll do the same process for B. I'm just going to write out the digits here. 1, 8, 6, 8, 0, 1, 5, 6, 4, and 6. Here's the ones position, the tens position, the hundreds position, and we just go down the line here. And we repeat. We then go ahead and multiply. 1 times 6 is 6. 8 times 2, 16. 6 times 3 is 18. 8 times 1 is 8. 0 and 5, that's 0. 1 times 4, that's 4. Here's 30. 12, 12, and 6. Again, we're going to add all these up. If the sum of these numbers is divisible by 7, then this whole number is divisible by 7. So we're going to add all these up. And it comes out to be 112. Now we can repeat the process. Rather than using our calculator to go ahead and do the division, we can just repeat the process. So we'll go 1, 1, 2. Here is our ones position, our tens position, and our hundreds. 1 times 2 is 2. This is 3. And this is 2. We add them up. 2 plus 3 is 5, plus 2. That's 7 without a doubt. 7 is divisible by 7. So therefore 1,868,015,646 is divisible by 7. And let's try C. So I'm just going to write out the digits here. 4, 9, 7, 6, 8, 8, 4, 7, 8, 6, 2, 3, 1, and 2. Here is our ones position, then our tens position, and we're just going to go down the line here. And we repeat. We repeat as often as we can. And then we multiply. 4 and 3, 12. 9, 35. 24. 48, 16, 4 times 3 is 12, here's 7, 8 times 5, that's 40, 6 and 4, that's 24, 6 times 2, that's 12, 3 times 2 is 6, 1 times 3, 3, and this is 2. Then we sum all these up. If the sum of these numbers is divisible by 7, then this whole number is divisible by 7. So this adds up to 250. And again, rather than using our calculator, we can repeat the process. So we'll take 2, 5, and 0. Again, this is our ones position here, our tens position, and our hundreds position. 2 times 2, 4. 5 times 3, 15, and this is going to be 0. 4 and 15, that's 19. We know that 7 goes into 19 2 times with 5 left over. But even if you weren't sure about that, we can do the process again. We can do 1, 9, and then do 1 and 3. 1 times 3 is 3. Here's 9. 9 and 3, that's 12. 7 goes into 12 once with 5 left over. Or if you weren't sure, we could repeat it again. Here's our 1's position. Here's our 10's position. This is 3. This is 2, and 3 and 2 is 5. So 7 does not divide into this large number here, but if we were to divide it into that large number, it would give us a remainder of 5. I'm just going to put it up here. It will give us a remainder of 5. So this process is very convenient, and there you go.